Question 18. There's a circuit for the parallel part and another resistor in series. So 1.5 volts here, voltage here is 4.2 volts. Okay, the EMF, the power supply is 4.2. Calculate the current in the resistor. Well, the current is just going to be potential difference divided by total resistance. So how do we work out the total resistance? You get 1 mark for working out the resistance of this part here. So 1 over the resistance here is equal to 1 over 120 plus 1 over 60. That's going to be 3 over 120. So the resistance is 120 over 3, 40 ohms. First mark. If this part is a 40 ohm resistor, the total resistance, RT we'll call it, is equal to 40 plus 33. What's the potential difference? Well, the potential difference, look at the signs. Okay, current's being pushed that way by this one, that way by this one. The total potential difference is going to be 4.2. Take away 1.5, which is 2.7 volts. So there we go. We now have 73 ohms there. Stick the numbers in. 2.7 divided by 73. Current is 0.037 amps. Answer. 18, part 2. The variable power supply is now decreased from 4.2 to 0. Describe the effect on the current. Make sure you talk about current in the 33 ohm resistor. 2 marks. As I reduce this voltage here, okay, the current flowing will reduce because the potential difference in the circuit will reduce up to the point where this one is 1.5 volts. Then current ceases to flow. If this is less than 1.5 volts, current will flow in the opposite direction. You write any 2 points, you get 2 marks. So you could write current decreases when up to 1.5 volts on the variable power supply. Current equals 0 at 1.5 volts, and the current changes direction when its voltage is less than 1.5 volts. Okay, you could even have the current also increases in the opposite direction, of course, when it's less than 1.5 volts. 18, part B. Students are investigating the power dissipated. To determine the power, the students determine the power in the fixed resistor R, or in the external resistor I should say. Show that the points plotted. Okay, you've got the points plotted here. Now, if you look at this graph, it looks something like this. So one of the first things I would do is plot a graph. Now you can see there's probably a couple of points missing here, maybe at least one at 2 ohms. Could be slightly high, could be slightly low, we don't quite know, but that looks something right. Okay. You also know that the maximum power is when the external resistance R is equal to the internal resistance. So that's somewhere around here, probably about this point. The external resistance is equal to the internal resistance, we get maximum power. That's the physics you need to know, so let's write that in our answer. Describe with the help of a suitable circuit diagram, we must have a circuit diagram, how the students have determined P and R and use it to calculate or estimate the internal resistance r. Discuss any limitations. So answer each of these parts, you'll get 6 marks. So I guess a circuit diagram, you will need something like a battery, a external resistance, that can be changed, variable resistor. We need a voltmeter either side of that. We need an ammeter in the circuit. Something like that will be absolutely fine. How do you find power? Well, power is equal to current times voltage. You get a mark. Resistance is voltage divided by current. State both of those. Get the mark. You could of course use I squared R or even V squared over R, but I would advise using the easiest one. You're halfway to answering the question now. You need to have a sketch of the graph, which we've got on the opposite page, looking at something like this, where this value is about 2 ohms. You should therefore be able to estimate the internal resistance is about 2 ohms. Anywhere between about 1 and 3 would be acceptable, I guess. Now, what are the limitations? You possibly want more data. Specifically, a point at 2 volts, or 2 ohms rather, when the external resistance is 2 ohms. Essentially, you stick all that down, you get 6 marks. Remember, however, this is an impression question, so you need to write good English, not just symbols. But if you've followed a logical pattern, you should get full marks.